children, good morning. Today we are going to solve 3 and 4 bits of first question from exercise 3.3 of a polynomials chapter class 10. Let's see what is the given question. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. So first we need to find zeros of these given polynomials and next verify the relationship between the zeros and the coefficients. So now move on to third problem, that is 6x square minus 3 and minus 7x. This is the given polynomial. So see here, what is the highest power of this polynomial? 2 is the highest power of this polynomial. So it is quadratic polynomial. Okay. So what is the general form of quadratic polynomial? Ax square plus bx plus c. It is the general form of quadratic polynomial. Here a is the coefficient of x square, b is the coefficient of x and c is the constant term. Now you need to understand what is the relationship between zeros and the coefficients of the terms. So by factorizing this quadratic polynomial, you will get two zeros. You will get two zeros. For quadratic polynomial, we have at most two zeros. So let us assume those zeros as alpha and beta. Alpha and beta. When you add these two zeros, you will get the same answer as by taking off minus coefficient of x, that is b, divided by coefficient of x square a. Okay, when you add these two zeros, you will get the answer same as minus of coefficient of x divided by coefficient of x square, that is a. Okay, second case is when you multiply those two zeros, you will get the same answer as constant term, that is c, divided by coefficient of x square is a. Okay, when you add alpha plus beta equal to minus b by a, when you multiply those two zeros, alpha into beta equal to c by a. These are the relationship between zeros and coefficients. Now we need to check how are these relationship would be for these questions. Okay, so compare this given polynomial with quadratic, general form of quadratic polynomial. Comparing with the general form of quadratic polynomial, then a is coefficient of x square, a equal to 6, and next b is coefficient of x. Here see, the given polynomial is in order. Let me write in order first. 6x square minus 7x minus 3. Okay, now what is the coefficient of x? B is minus 7, and next constant value, that is c equal to minus 3. So what is the first step? We need to find these zeros of this given polynomial. So find the zeros of this polynomial. 6x square minus 7x minus 3. How can we find zeros of this polynomial? By splitting this middle term into two terms. Okay, minus 7x. What is the middle term? That is minus 7x. We have to split this middle term into two terms. How can we find these two terms? By product of 6x square and minus 3. 6x square into minus 3, that is 6 3s are 18, minus 18x square. Okay, minus 18x square. What are the factors of minus 18? 6 3s are and 18 ones are 18 and 2 9s are also 18. 2 9s are also 18. Here see, when you add these two factors, you have to get middle term, that is minus 7x. When you multiply these two terms, you have to get this product. Okay, these two conditions should be satisfied. Okay, first check. When you add 6 plus 3, will you get minus 7x? No, it is not possible. Next, when you add 18 plus 1, that is 19. It is not minus 7. So it is cancelled. Next, when you take 2 and 9, if you subtract 2 from 9, 9 minus 2 equal to 7. Okay, so here we are getting minus 7. Here 7 is, we have minus. So put the negative symbol for bigger number, minus 9. Here we have x square. Keep 1x for 9 and keep 1x for 2. Okay, so now if you multiply 9 2s are 18, plus into minus minus, x into x, x square. So when you multiply these two terms, we are getting minus 18x square. When you add these two terms, we are getting minus 7x. So we can write in place of minus 7x, minus 9x plus 2x. So 6x square minus 9x plus 2x. Here we have minus 3, constant term, right? Minus 3. Okay. So here 6x square minus 9x. In these two terms I am taking common. In these two terms I am taking common 3x. Here 6 in 3 table 2 times. 1x is common. We have left with 1 common. 1x. In between we have minus. Right, minus. And 9 in 3 table 3 3s are 9. 1 3 is common. We have left with 1 3. Already x is common. Okay. Now close the bracket. Here in between we have plus symbol and 2x minus 3. Here I am taking plus 1 is common. If 1 is common, we have left with 2x and minus 3 into 1. 1 is common, we have left with minus 3. Okay. Again in these two terms, here plus is separating these two terms. Okay. Again in these two terms, 2x minus 3 is common. I am taking 2x minus 3 is common. When you take 2x minus 3 is common, we have left with here 3x plus 1. 3x plus 1. So to find the zeros, equate these two equations equal to 0. 2x minus 3 equal to 0 and 3x plus 1 equal to 0. Here x equal to 3 by 2. 2x equal to 3. Minus 3 moves from LHS to RHS is equal to plus 3. 2x equal to 3. X equal to 3 by 2. Here x equal to minus 1 by 3. So now these are the zeros of this polynomial. 3 by 2 and minus 1 by 3 are the zeros of this given polynomial. 3 by 2 and minus 1 by 3 are the zeros of the given polynomial. Okay. Now compare these zeros with coefficients of the terms, verifying the relationship between the zeros and coefficients. Let us assume these zeros. First, alpha equal to 3 by 2 and beta equal to minus 1 by 3. What is the first case? Sum of two zeros should be equal to minus b by a. Alpha plus beta equal to minus b by a. Okay. First substitute what is the alpha? Alpha value 3 by 2 plus what is the beta value? Minus 1 by 3 equal to minus b by a. First write minus. What is the b value? Minus 7 divided by a. What is the a value? 6. Okay. Sum of two zeros equal minus b by a. Alpha plus beta equal to minus b by a. Alpha is 3 by 2 plus beta value is minus 1 by 3 equal to minus, here I have minus, write minus, b value is minus 7 divided by a value is 6. So 3 by 2 plus into minus 1 by 3. 3 by 2 minus 1 by 3 equal to minus into minus plus 7 by 6. On right side we have 7 by 6. Okay. So here we have different denominators. Take LCM. 2 3s are 6. Here 6 2 table 3 times and multiply 3 with numerator, that is 3. 3 3s are 9 and again 6 in 3 table 2 times, multiply 2 with numerator, that is 1. 2 ones are 2, equal to 7 by 6. 9 minus 2 equal to 7 by 6. So we have proved alpha plus beta equal to minus b by a. Okay. Next case, product of two zeros. Product of two zeros equal to, what is the formula? C by a. Alpha into beta equal to C by a. Okay. So what is the alpha value? 3 by 2. Beta value is minus 1 by 3 equal to C value is minus 3 divided by a value is 6. Okay. So here numerator we have 3, denominator we have 3, get cancel. We have minus 1 by 2 equal to 3 ones are 3, 3 twos are 6, minus 1 by 2. Okay. Here we have same answers. Alpha into beta equal to C by a. This is the relationship between zeros and coefficient of the terms. Now move on to fourth problem. So here see 4u square plus 8u. Again it is a quadratic polynomial. Compare this polynomial with the general form of quadratic polynomial. Comparing with general form of quadratic polynomial. Okay. So that is ax square plus bx plus c. Here we have a value coefficient of x square equal to 4. B is coefficient of x, that is 8, and c is, here we didn't have any coefficient, that equal to 0. Okay. So first we need to find zeros of this given polynomial. 4u square plus 8u. If you see here in these two terms, 4u is common. Here 4 and 8, 4 table 8 is cancel. 4u is common. If you take 4u is common, u square. Already one u is common. We have left with u plus and 8 4 table 2 times 4 2s are 8. U is common. Okay, we have left with only 2. U plus 2. So to find the zeros, equate these two equal to 0. 4u equal to 0 and u plus 2 is also equal to 0. U equal to 0 by 4 equal to 0 and u equal to minus 2. So 0 and minus 2 are the zeros of this given polynomial. 0 and minus 2 are the zeros of the given polynomial. Let us assume alpha equal to 0 and beta equal to minus 2. So now we need to verify the relationship between zeros and coefficients of the terms. So verifying relationship between the zeros and coefficients. What is the first relationship? Sum of two zeros equal to minus b by a. Alpha plus beta equal to minus b by a. So now what is the alpha value? Is 0 plus beta value is minus 2 equal to minus b by a, right? First minus, what is the b value here? 8. 8 divided by a value is 4. 0 plus into minus, minus 0 minus 2 equal to minus 2 equal to 4 ones are 4 twos are minus 2. So we have proved alpha plus beta equal to minus b by a. Okay. Next, product of two zeros. Product of two zeros equal to C by A. Formula is alpha into beta equal to C by A. Okay, what is alpha value? 0. What is the beta value? Minus 2. Equal to what is the C value? 0 divided by A value is 4. 0 into anything equal to 0. Equal to 0 divided by 4 equal to 0. So we have proved alpha into beta equal to C by A. These are the relationship between zeros and coefficients of the terms. Thank you for watching.